Coinciding with America's bicentennial, the Viking spacecraft would be launched on a journey to Mars in search of answers. The program called for 4 spacecraft, 2 to orbit the planet and 2 to land on the surface. The Viking program was the largest, most intensive planetary expedition NASA had ever embarked upon. Preparations for the mission demanded years of research and development and the efforts of thousands of individuals. Viking's primary mission: search for life. On earlier missions, the mariners unveiled the barren surface of Mars, extinguishing ideas of highly civilized communities living on the planet. However, the mariners were above the surface, not on it. Was there something being left unseen? We could get closer, and with better cameras. It was time for another look. On August 20th, 1975, a Titan Centaur launched Viking 1 into space on a mission to Mars. About 2 weeks later, Viking 2 followed its path to the Red Planet. For almost a year, the world waited for highly speculative historical evidence. While the Vikings traveled to their destination over 1 million miles away, the world buzzed with excitement, anticipating their arrival. This was, after all, a new frontier about to be discovered. Now it was no longer just the talk of science fiction. A spacecraft was about to land on another planet. On June 19, 1976, Viking 1 arrived at the planet Mars and immediately began sending back photographs. 134,000 bits of information arrived every second. Viking's first lander touched down on Chryse, Planitia on July 20th, 1 month later. Viking 2 joined them on August 7th, and its lander, targeted for Utopia, Planitia, landed on September 3rd. For the next 6 years, the Viking mission would take over 55,000 photographs, sending to Earth images of volcanoes, dust storms, evolving polar regions, and immense canyons. Evidence of lake beds, stream channels, and lava plains painted a picture of a very different Mars from a time long ago. The landers performed a multitude of experiments, biological and chemical, day after day for over 3 Martian years, digging, retrieving, and analyzing. And yet, not one trace of organic material was found. And so, many who held great expectations for the discovery of life on Mars were let down, left disappointed. However, for each question that the
9. We have ignition sequence start. The engines are on. 4, 3, 2, 1, 0.
Sideways.
Saturn V to 7 times the speed of sound.
The second stage cut in. Big bang.
At 40 miles high, it's...
All sources show that the stage is burning perfectly.
The third stage fires twice. First, the boost into orbit. The second burn takes the crew of Apollo 8 where no men have ever been.
Mariner 4. The scientific instruments included a helium magnetometer, mounted on the waveguide leading to the omnidirectional antenna, to measure the magnitude and other characteristics of the interplanetary and planetary magnetic fields. An ionization chamber/Geiger counter, mounted on the waveguide leading to the omnidirectional antenna near the body of the spacecraft, to measure the charged particle intensity and distribution in interplanetary space and in the vicinity of Mars. A trapped radiation detector, mounted on the body with counter-axes pointing 70 degrees and 135 degrees from the solar direction, to measure the intensity and direction of low-energy particles. A cosmic ray telescope, mounted inside the body pointing in anti-solar direction, to measure the direction and energy spectrum of protons and alpha particles. A solar plasma probe, mounted on the body pointing 10 degrees from the solar direction, to measure the very low energy charged particle flux from the Sunday. A cosmic dust detector, mounted on the body with microphone plate approximately perpendicular to the plane of orbit, to measure the momentum, distribution, density, and direction of cosmic dust. A television camera, mounted on a skin platform at the bottom center of the spacecraft, to obtain close-up pictures of the surface of Mars. This subsystem consisted of 4 parts: a Cassegrain telescope with a 1.05 degrees by 1.05 degrees field of view, a shutter and red/green filter assembly with 008s and 020s exposure times, a slow-scan Vidicon tube which translated the optical image into an electrical video signal, and the electronic systems required to convert the analog signal into a digital bit stream for transmission. If you like my video, please click on the like button, and if you like my channel, please click on subscribe button. In my next video we will talk about Mars Oath Finder and Mars Curiosity rover.